In this video for Positive Maths, we're going to have a look at problem solving involving number systems. So the first problem we're going to look at is from the 2013 paper 1, and it's question 1. The columns in the table below represent the following sets of numbers. So we have natural numbers, integers, rational numbers, irrational numbers, and real numbers. We need to complete the table by writing either yes or no into each box, indicating whether each of the numbers is or is not an element of each. Okay, so what we're going to do is we're going to look at each column and answer yes or no. You could also look at the numbers and answer yes or no across the way in rows, but we're going to do it by identifying the characteristic of each set of numbers. Okay, so we're starting off with natural numbers. So these are positive whole numbers. So if they're not positive, or if they're not whole numbers, then they're not natural numbers. So we'll take the square root of 5. If we find the square root of 5, it's 2.23606 continuing on. So therefore, we're going to answer no. It's not a natural number. 8 is, minus 4 is not because it's negative. 3.5 is not because it's not a whole number. And 3 pi over 4, again, it's not because it's not a whole number. Okay, now let's look at the integers. Integers, these are positive and negative whole numbers. So again, if they're not positive or negative or whole numbers, then they are not integers. So again, our square root of 5, not an integer. 8 is, minus 4 is an integer. It's a negative whole number. 3.5 is not because it's not a whole number. And 3 pi over 4 is not because it's not a whole number. So the next column we're going to look at is rational numbers. So what we want to recall here is that the set of rational numbers, any number that can be written as a fraction. Okay, so again, it's positive and negative numbers, but it has to be able to be written as a fraction. So the square root of 5 cannot be written as a fraction, therefore it's not a rational number. Okay, then we can say really that it is an irrational number. So we can do really these two columns at the same time. So a number is either rational or irrational. It cannot be both. Okay, so let's look at the number 8. 8 can be written as a fraction, so 8 over 1. Therefore, it is a rational number, so it's not an irrational number. Minus 4 can be written as a fraction, so it's rational, it's not irrational. 3.5 can be written as a fraction, so it's rational. And 3 pi over 4 cannot be written as a fraction, therefore it's not rational, so it is irrational. Okay, and then our last column. Real numbers. This is the set of all numbers, so it's all positive or negative numbers. Okay, so then we can put in yes for every single one of these. So every number is a real number. For part 2 of this question, it asks, in the case of the square root of 5, explain your choice in relation to the set of irrational numbers. So, i.e., give a reason for writing either yes or no. So, for the square root of 5, we put that yes, it is an irrational number. So we have to explain our answer. So we explain it by saying that the square root of 5 cannot be written as a fraction. So the next question we're going to look at is part B from the same question we just saw before. So if they use the properties of surds to show that the square root of 98 minus the square root of 18 plus the square root of 2 simplifies to 5 times the square root of 2. So the property of surds that we need to know for this question, we need to know that if we have the square root of a by b, that's equal to the square root of a multiplied by the square root of b. So just as an example, if we have the square root of 18, we can break that up into the square root of 9 by the square root of 2. So that would simplify to be 3 times the square root of 2. So that concept is really important for this question. Okay, so we want to simplify the square root of 98 minus the square root of 18 plus the square root of 2. We want to simplify it to 5 times the square root of 2. So what we're going to do is we're going to break up 98 and 18. We're going to rewrite the square root of 98 as the square root of 49 by the square root of 2. And we're going to rewrite the square root of 18, so the square root of 9 by the square root of 2. And then plus the square root of 2. So the reason why we've broken them down like this, and we haven't broken the square root of 18 into the square root of 6 and the square root of 3, is because for this question we really want to simplify it down to 5 times the square root of 2, so that's why we've chosen these factors. Okay, so our next line is going to be 7 times the square root of 2 minus 3 times the square root of 2 plus the square root of 2. So 7 times the square root of 2 minus 3 times the square root of 2 is going to give us 4 times the square root of 2 plus the square root of 2, and that's going to simplify to be 5 times the square root of 2. So therefore we have simplified, and we have found 5 times the square root of 2. The next problem we're going to have a look at is from the 2012 Paper 1 Question 1. So by rounding to the nearest whole number, estimate the value of 3.89 by 7.24 minus the square root of 8.94 over 8.52 minus 3.65. Okay, so two parts to this. First of all, we have to round, then we have to find the estimate of the value. Okay, so 3.89, that's going to round to 4, multiplied by 7.24 will round to 7, and then minus the square root of 9. That's going to be over 9 minus 4. So our next line, we're going to have 4 by 7 minus 3 all over 9 minus 4. So we multiply before we subtract. So the next line will be 28 minus 3 over 5, which will give us 25 over 5, which will give us 5. So our estimate is equal to 5. The second part of this question, they ask us to evaluate the same problem and give our answer correct to 2 decimal places. Okay, so we really need to pay attention here to the order in which I'm doing things. So the order of operations. So I'm going to do each step in a different color so we can see what order I'm performing the operations in. So I find the square root of 8.94 and I've subtracted 3.65 from 8.52. Okay, the next line then. So I need to multiply before I can subtract. So 3.89 multiplied by 7.24 is going to get me 28.1636. So now I can subtract 2.99 from 28.1636 and I get 25.1736. So that's over 4.87. So my answer is going to be 5.1691. So that's 4 decimal places. Now, we just have to round to 2 decimal spaces for this answer. So it's going to be 5.17. So for these questions, we really need to be familiar with the order of operations. So, do we know when we need to multiply, when we need to subtract? A simple way of remembering this is by using BIMDAS or BOMDAS. There's several different variations of this, but it's the same idea. So we have to deal with brackets first, then the order or the indices, then we multiply, then we divide, and finally we add or subtract. Okay, so for the third part of this question, we need to simplify the square root of 5 multiplied by the square root of 2 plus the square root of 5 minus the square root of 8 by the square root of 2 minus the square root of 5 without the use of a calculator. We need to express our answer in the form of a plus b by the square root of c, where a, b and c are all natural numbers. Okay, so we need to simplify. So the square root of 5 by the square root of 2 plus the square root of 5, so we'll just write out the expression that we're given. Okay, so we need to multiply in to get rid of our brackets first. So with the square root of 5 by the square root of 2 first of all, plus the square root of 5 by the square root of 5, minus the square root of 8 by the square root of 2, minus the square root of 8 by the square root of 5. Or plus, sorry, for the last one, plus the square root of 8 by the square root of 5. So I'm going to get the square root of 10 plus 5 minus the square root of 16 plus the square root of 40. So my next line, I'm going to have the square root of 10 plus 5 minus 4 plus the square root of 40. So I'm getting closer to simplifying. Okay, so plus 5 minus 4 is going to give me 1. So then I have plus the square root of 10 plus the square root of 40. 1 plus the square root of 10. Now I'm going to break up the square root of 40 so that it's plus the square root of 4 by the square root of 10. So now I have 1 plus the square root of 10 plus twice the square root of 10. So this is going to give me 1 plus 3 times the square root of 10. So we have our answer. We have it written in the form of a, where 1 is a, plus bc, where 3 is b and 10 is c. And 1, 3 and 10 are all elements of the natural numbers, so we know we have found the correct solution. For more information, visit www.PositiveMaths.ie, email us at info@PositiveMaths.ie, and find us on Facebook and Twitter. Thanks for watching.